This video is presented to you by www.testprepadda.com. Dear students, from this session, I will start another part of organic chemistry, that is isomerism. After studying this part, you will be able to write different compounds of a given molecular composition. Now, first of all, what is isomerism? Different compounds which have same molecular composition, or I can say same molecular formula, are called isomers, and the phenomenon of existence of these isomers is called isomerism. These isomers may have different properties due to difference in the connectivity of atoms or groups, or due to difference in the relative orientations of atoms or groups in the space. For example, if I take a composition C4H8, this is a composition, molecular composition. Now, if I try to write different compounds of this molecular composition, I can say CH3, CH2, CH double bond CH2, and another compound I can write CH3, CH double bond CH, CH3. Now just see these two compounds. In these two compounds, you can say little bit difference in the connectivity. Where is the difference? Here if I say 1, 2, 3, 4, here 1, 2, 3, 4. You can see here double bond is present at first carbon, between carbon 1 and 2. Here you can say the double bond is present at second. So basically between second and third carbon. So connectivity is different. So these two compounds we can write with the help of this molecular composition. Now for the second one, if you say C double bond C, I can place CH3 here, H here, CH3 here, H here. With respect to this C double bond C, I can change the orientations of atoms and groups. Here you can see for these two. For these two, you can say connectivity is same. The double bond is present at second carbon only. Where is the difference? Difference is of relative orientations of atoms and groups. Here you can say with respect to double bond, these two methyl groups on same side, while here the two methyl groups are on opposite side. So for these two compounds, we can say there is a difference in the structure, while here difference is of orientations of atoms and groups. And based on this, we can classify this isomerism into different categories. So what are the different types of isomerisms? Here you can see different types of isomerisms. First, based on the difference in the structures, structural isomerism, and here that based on the orientations of atoms or groups in the space isomerism, and that structural is further classified into chain isomerism, ring chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism, and stereoisomerism is further divided into configurational isomerism and conformational isomerism. And in configurational isomerism, we have to study geometrical isomerism and optical isomerism. So these are the different types of isomerisms. One by one, we'll discuss all these. First, I'll start with the structural isomerism and its parts. So, what is the structural isomerism? The definition says different compounds which have same molecular composition or formula but different structures due to difference in the connectivity of their atoms are called structural or constitutional isomers, and this phenomenon is called structural or constitutional isomerism. For example, if I take CH3 CH2 OH, and another example CH3 O CH3. This is an alcohol, ethyl alcohol, and this is ether, dimethyl ether. You can see the molecular composition of these two compounds is C2H6O. Okay, but what is the connectivity? Here you can say CCO. This is the connectivity in this compound, while here the connectivity is COC. Now you can see the difference is in the connectivity of atoms, and that is why we say constitutional or structural isomers. So this is about structural isomerism. As I told you, structural isomerism is further classified into chain, ring chain, positional, functional, metamerism, and tautomerism. So I will discuss these isomerisms one by one. First, chain isomerism. What is this? Different structural isomers which differ in their carbon chains are called chain isomers, and this phenomenon is called chain isomerism. Dear students, please note that here in chain isomerism, the difference is of number of carbon atoms in the parent chain. Number of carbon atoms in the parent chain. For example, if I say normal butane, so normal butane I can write CH3, CH2, CH2, CH3. This is normal butane. Now, how many carbon atoms are there in the parent chain? 4 carbon atoms. Now, if I write 3 carbon atoms in the parent chain and give one branching like this. So, now 3 carbon atoms in the parent chain. So, the difference is of carbon skeleton. Carbon skeleton. 4 carbon atoms in the parent chain, 3 carbon atoms in the parent chain. So these two are chain isomers. I'll take another example. If I write normal pentane, this is normal pentane. Okay, now give one branching. 4 carbon atoms and one branching I can give like this. Okay, so this is isopentane. We have done this in nomenclature. Now, one more branching. You can see how many carbon atoms in the parent chain? 5 here. Here how many? 4 here. Here how many? 3 here. So the difference is in the carbon skeleton. And that is why these three are chain isomers. I'll take another example here where I'll take a functional group. CH3, CH2, 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 COOH. Now, keeping the functional group same, we have to make the difference where? In the carbon skeleton. So I can write CH3, CH, CH3, CH2, COOH. Now see, here the number of carbon atoms in the parent chain is 4, and here the number of carbon atoms in the parent chain is 5. So where is the difference? Difference is in the carbon skeleton of parent chain. So these two are also the example of chain isomerism. Point is clear? Now I will talk about ring chain isomerism. Ring chain isomerism. Two isomers, one having an open chain structure and the other having a ring structure, are called ring chain isomers. If I write, for example, cyclopropane. So what is the molecular composition? 3 carbon atoms and how many hydrogen atoms? Here I can say CH2, CH2, CH2. So 6 hydrogen atoms. With the help of 3 carbon and 6 hydrogen atoms, can we write open chain? Yes, we will try. C, C, C. 3 carbon atoms. Now hydrogen atoms will be attached with carbon. If I attach 3 hydrogen here, so remaining 3 I can attach, like 1 I give here, 2 I give here, and 1 double bond. So you can say this is the open chain compound with the molecular formula C3H6, and this is a cyclic compound with the molecular formula C3H6. So both have got same molecular composition but different structures. One is in ring form and another one open chain. That is why these two are ring chain isomers. Dear students, in another session, I will tell you about how to compare the unsaturations of two compounds, or better I say, how to find the degree of unsaturation. That will help you in writing different isomers, especially structural isomers. My point is clear. So this is about ring chain isomerism. Now I will talk about position isomerism. Positional isomerism. Different structural isomers which have identical carbon chains but differ in the position of the functional group are called positional isomers, and the phenomenon is positional isomerism. For example, if I take CH3, CH2, CH2, CH2OH. Now here you can see the OH, that is the functional group, is attached with carbon 1. If I write another compound where I attach this OH at the second, the molecular composition will remain same. In both the compounds, you can say 4 carbon atoms and how many hydrogen? 3 to 5 to 7 to 9, 1, 10. So I can write H10O. Here also you can see same molecular composition, but the position is different. Position of functional group. And please note, here the skeleton, carbon skeleton of the parent chain, same. That is why the two are not chain isomers. The difference is of position of the functional group. That is why the two are positional isomers. Now if I write another structure like CH3, CH, CH3, CH2, OH. Students, please note now. This is first carbon, this is second carbon, this is third carbon. Now you can see the number of carbon atoms in the parent chain different. That is why this will not be the positional isomer of these two compounds. This will be what? Chain. Here there is a difference in the chain. Position still one. My point is clear. So if I say this compound as A, this as B, this as C, then I will say A and B. These two compounds are positional isomers, and compound A and C, or I can say B and C, these two are what? Chain isomers. My point is clear. Now, similarly, if I take another example like this, here you can see uh, 1, 2, 3, 4. 4 carbon atoms are there. So you can write the molecular composition also, C4H. Now 3 hydrogen atoms will be attached here, CS3 here, CH2, 3 to 5, and then 1 hydrogen here, 2 hydrogen here. So 3 to 5, 1, 6 to 8, C4H8. Now if you want to write position isomer of this, then you have to change the position of double bond, which I can write like this. You can see this is the double bond. Now 1, 2, 3, 4. But if I write compound like this, I place double bond here. So you can see now the skeleton of carbon is this. So total number of carbon atoms now is 3 in the parent chain. So this will not be the positional isomer of these two compounds. So if I name these compounds as P, Q, R, then compound P and Q will be the positional isomers, and PR, or I say QR, these two will be the chain isomers. Chain isomers. So you can easily identify the difference in the chain isomerism and positional isomerism. Okay, students, in the next lecture, I will tell you about the degree of unsaturation. And I will tell you the methods to write the isomers of compounds with the help of degree of unsaturation. Okay, all the best. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.